Okay. The 18th problem. It is 1 by 1 plus secant x dx or 1 by 1 plus cosecant x dx. This is the different model. You see, this is 1 by 1 plus 1 by cos x dx, not in that type of method, that is the 17 method. It is after LCM cos comes up, cos, this is 1 plus cos x dx. Will agree? This is cos x. It is cos x of 1 minus cos x by 1 plus cos x into 1 minus cos x. 1 minus cos square x. That is the sin square x dx. It is cos x by sin square x dx minus integral cos square x by sin square x dx. This 1 by cos is cot and 1 by sin, one more sin is cosecant x. Okay, na? Dx minus this is cot square x. But for cot square x, integration directly will not be solved. Cot square x means it is cosecant square x minus 1 dx. So this is minus cosecant. Direct formula is there. For cosecant cot x integration to cosecant x minus cosecant x. Minus cosecant is plus cot x. Minus into minus plus x plus c. Okay, na? That is the same way you may solve that one also. And one more thing. Integral 1 by 1 plus sin x cos x dx is there. Can you solve it? This is also asked in the previous, not in CET, the J means and the advanced, I8 advanced problem. You see, it is not possible to solve it directly. This is a standard method. Put you see, it is 0. Sin x minus cos x is equal to t. Okay, na? Then it is cos x plus sin x dx, okay, na? Is equal to t. Okay, na? But it is not there. But we may. And making the square on both sides, it is sin square x plus cos square x. 1 minus 2 sin x cos x is equal to t square. This is okay. It is after differentiation. Again I am taking that one. Here it is sin x cos x is equal to 1 minus t square by 2 now. So that is there. Okay? Again, here the thing is, it is directly it will not come. 1 by 2 and 2. It is 2 sin x minus cos x plus sin x plus cos x. Like this you take it. So cos cancels. We get 2 sin. Okay, na? 2 sin by 1 plus it is sin x cos x dx. Okay, na? Is it correct? Here it is sin is there. It is sin x. In the problem it is I forgot that one. Sin x by 1 plus sin x cos x. So we multiply with 2 and divide with 2. Divide 2 sin x. 2 sin x is there. Cos x minus plus cos x will cancel. We get the same. Okay, now don't confuse. So it can be, see, 1 by 2 sin x minus cos x by 1 plus sin x cos x dx plus 1 by 2. It is sin x plus cos x by 1 plus sin x cos x dx. There are two different problems. Okay, now we assume like this. It is related with the first one, and you see it is sin x minus plus cos x is equal to some y we assume. It is cos x minus sin x dx is equal to dy na. Okay na? And I am taking again squaring on both sides. It is 1 plus 2 sin x cos x is equal to y square. So sin x cos x is equal to 1 minus y square minus 1 by 2. Don't confuse. At one time sin x cos x is 1 minus t square by 2. At other time it is sin x cos x is y square minus 1 by 2. It is according to the two problems. Related with the two problems. So I take this assumptions differently. So you see, for first one which can be taken as, you see, this one can be taken. Why that? Why? Because cos x minus sin x dx is equal to dy. Here sin x minus cos x is there, or otherwise this is sin x minus cos x dx is minus dy na. We may take it as a minus dy. So here it is 1 by 2, it is minus dy by 1 plus, don't confuse, 1 plus y square means, sin x plus cos x, we are applying this one there. It is total and don't confuse, sin x minus cos x dx is here, dy is there, minus dy is there. And it is not there, we are assuming. But here sin x cos x is y square minus 1 by 2. So it is y square minus 1 by 2 is there. Plus 1 by 2. Here sin x plus cos x dx is nothing but dt. Here is sin x cos x 1 minus t square. So it is dt by, simply dt by 1 plus, here sin x cos, in this assumption it is 1 minus t square by 2 is there. Okay na? Like that. Okay na? Now it is 1 by 2 minus, it is 2 by, it is 2 LCM, 2 minus 1 is 1 only, 1 plus y square dy. Don't confuse, minus is sent to that side and 2 goes up after LCM, 2 minus 1 is 1 only. And here also it is 1 by 2 integral 2 by 2 plus 1 3 minus t square. This 3 again root t square dt. Okay na? 2 cancel here, 2 cancel. It is minus 1 by 1 plus y square is tan inverse y. Okay na? Tan inverse y. And here it is 1 by 2a. Already we solved it. Log of root 3 plus t by root 3 minus t. What is tan inverse y? What is y? Y is sin x plus cos x. Okay na? And 1 by 2 root 3. It is a log of, what is t? T is in our assumption, it is sin x minus cos x by root 3 minus of sin x minus cos x. Okay na? Plus c. Okay na? Yeah, pass. Now 20. It is integral. It is a problem. 21 is 1 by sin x plus cos x dx is there. Okay na? The related problem is integral 1 by 3 sin x plus 4 cos x dx. Maybe. Okay? Also, very good problem. You see, it is 1 by root 2 into 1 by root 2 sin x, 1 by root 2 cos x dx. Will agree? It is 1 by root 2, okay. It is 1 by, sorry, let's cos 45, cos x plus sin 45. This is sin of 4 plus x dx. This is 1 by root 2 integral cosecant of pi by 4 plus x dx. This is 1 by root 2 cosecant x is log of tan of pi by 4, I mean x by 2. X by 2 means here x is pi by 4 plus x itself is x by 2. Don't confuse. It is 1 by 2. The log of tan of pi by 2 plus x by 2 plus c. Okay, now? Or 1 by 2 log of 1 by root 2. This is tan 90 means it is simply cot or otherwise simply leave out. It is only tan of pi by 4 by 2 pi by, this is 4. Pi by 8, sorry. Pi by 4 by 2 is pi by 8 plus x by 2. This is 2, yeah. Like this, we may solve this one. Suppose this one. How can you solve it? It is near, what is the necessary to multiply with root 2 and divide with root 2? Whenever in the trigonometry a cos x plus b sin x is, you divide with the root of a square plus b square. Here also, root of 3 square plus 4 square, 16 plus 9 is 25, 5. Root 25 means 5. So, here it is 5, 3 sin x by 5, 4 by 5 cos x dx. It is 1 by 5, here it is sin x cos alpha. Cos x sin alpha dx. What is alpha? You see that alpha is cos alpha. 4 by 5 3 by 5. That is 3, this is 5 by 4. Sin alpha 4 by 5. Yeah, it's correct. So it is 1 by 5 integral 1 by, this is sin of x plus alpha dx. 1 by 5 integral cosecant of x plus alpha dx. It is 1 by 5. It is log tan of x plus alpha by 2 plus c. Where, what is alpha? Alpha is tan inverse b by a. That is, you see, tan alpha is 4 by 3. So this is 4 by 3. That is the way. Okay, now, like that we may solve. Now, this is 21 integral. It is sin x by sin of x minus a square. It's a theory problem. We write it as sin of x minus a plus a by sin of x minus a dx. This x can be written as subtracting a minus a plus a. This is sin of alpha plus beta. Sin alpha, sin of x minus a cos beta plus cos of x minus a sin a by, this is sin of x minus a here also by sin of x minus a dx. It cancels. cos A integral 1 dx. Don't confuse. Integral cos A is sin A is wrong. Because we are differently integrating with respect to x, but here is cos A is there. It is a constant, sin A cos A dx plus sin A cos by sin is cot of x minus dx is there. So this is x integral 1 dx is x cos A plus sin A cot something is integral. It is a log sin of x minus plus c. Okay, like that you may solve problems. Right? Okay. Dear students, good morning. In the Super 60 calculus part, second PU, that is indefinite integrals, we solved 20 problems. In this video, we will continue it. The 21 problem. It is integral 1 by sin of x minus a into sin of x minus b dx, or integral 1 by cos of x minus a cos of x minus b dx. Okay, now this is of one set. Side is a round one. Round one. Integral 1 by sin of x minus a but cos of x minus b dx, or 1 by cos of x minus a sin of x minus b dx. The difference is there. In the denominator, sin cos. The same ratio is repeated. Ratio means trigonometric ratio. Sin or cos. Second time is sin cos or cos sin. This type of solution, integration, can be solved as it is integral. It is 1 by sin of b minus a. For this one I am solving. For the first one, sin or cos is there, we divide with 1 by sin of b minus a and multiplying with the sin of b minus a. This number x minus b constant, x minus a. The second one, b minus a, we have to take, multiply and divide. It is sin of x minus a and sin of x minus b dx. 1 by sin is nothing but cosecant of b minus a. This can be written as sin of x minus a minus x minus b. Will you agree? X cancels, minus plus b minus a is only. By sin of x minus a sin of x minus b dx. It is a cosecant of b minus a. You observe me. It is considered as alpha and it is a beta. Sin of alpha minus beta. Sin alpha cos beta. Okay na? Minus cos alpha sin beta. Okay na? Alpha means x minus a. I didn't write it here. Beta means x minus a. Here is understood. By this is sin into sin, again sin. Okay na? It is dx. It is a cosecant of b minus a. It's a constant. Cosecant of b minus a constant. You separate it. Sin cos by, this is sin. Will you agree? Sin and sin. Sin means sin of x minus a, first one. Sin of x minus b. dx. Minus integral here. It is minus integral cos sin by, this is sin into sin. Don't confuse. Cos means cos of x minus a. Sin here, sin of x minus a. First is x minus a, second one is x minus b. Here sin cancels, sin cancels. So this is cosecant of b minus a. We get here integral cos by sin. That means integral cot of cos by sin, cot. It is a second one. So x minus b dx. Minus integral here is also cos by sin. It is cot x minus a. Don't confuse. See there. Here is the second part. First sin cancels. Cos of x minus b by sin of x minus b. So cot of x minus b. Here is the first one. Cos of x minus a by sin of x minus a is cot of x minus a. That is equal to cosecant of b minus a. It is into integral cot something. Cot x is log of sin of x minus b minus log of here also cot something x minus a sin of x minus a. The integration for the cot x is integral cot x dx is log of sin x. So it is integral solved log something minus log something. Log a minus log b. That is log of a by b. Okay, na? X minus b by sin of x minus a plus. So it is cosecant of b minus a. It is over. Not needed to write it once again. Okay, na? It is cosecant of log of log a minus log b by log of a by b. This is the answer. For the first one, in the denominator sin side or cos is there, you simply divide with the sin of b minus a. The second one also you can solve it. You try to solve it. The second one, the 1 by 1 is sin, another one is cos. For this one, you divide with the cos of b minus a and the cos of b minus a. With the cos of b minus a, you multiply and divide. This is x minus a, cos of x minus b dx. Okay, na? It is the secant of b minus a. It is, you see, cos of x minus a minus x minus b. Okay, na? B minus a can be written as x minus a minus x minus of minus plus b. B minus a, x cancels. Okay, na? Like that. By, as it is, the denominator is sin of x minus a, cos of x minus b dx. As it is, you solve it. Okay, na? Like that, we can. The next one. The second. Observe it. Integral x square minus 1 by x power 4 plus 1 dx square. It is taking x square as common. Okay, na? Here also x square is taken as a common. Dx. Because here the partial fractions or any formula not be applied. You may think that 1 plus x square whole square. X square whole square. Put x square is equal to t. 2x dx. There 2x dx is not there. So we have to apply this type method. There it is 1 minus 1 by x square by x square plus 1 by x square dx is there. Put x plus 1 by x is equal to some y. This term is not included in this one, but we have to take this one as y and differentiate 1 minus 1 by x square. For x1, 1 by x is minus 1 by x square dx is equal to dy. Okay, na? And make square on both sides. The x square plus 1 by x square plus 2 is equal to y square. Is it correct? Making square on both sides. A plus b square, a square plus b square plus 2ab. 2 into x into 1 by x. X cancels. So x square plus 1 by x square is equal to y square minus 2. So we may write for x square plus 1 by x square is y square minus 2. And this 1 minus 1 by x square dx is totally dy. So it is 1 by y square minus root 2 square dy. It is in the form of 1 by, in the very beginning I taught that one formulas. 1 by x square minus a square. 1 by 2a. It is log of y minus root 2 by y plus root 2 plus c. Very clearly it is 1 by 2 root 2. It is log of, what is y? Y is x plus 1 by x minus root 2 by x plus 1 by x plus root 2. Okay, na? That is the one problem. Similarly, integral x square plus 1 by x power 4 plus 1 dx is there. Okay, here also there it is a plus, here it is a minus. Take x square as common. If you take x square as common, you see the x square cancels 1 plus 1 by x square by x square plus 1 by x square dx. Okay, na? Now we substitute, put x, there we substitute x plus 1 by x. Here x minus 1 by x is equal to some other words. Thereby here it is a t. And differentiating 1 minus of minus 1 by x square, it is dt by dx. Okay, na? It is 1 plus 1 by x square dx is equal to t. Okay, na? Yeah. And make squaring on both sides. The x square plus 1 by x square minus 2 is equal to t square. There, again I am taking here x minus 1 by x whole square is nothing but x square plus 1 by x square minus 2 into x into 1 by x. X 1 by x cancels, the 2 is there. X square plus 1 by x square is equal to t square plus 2 is there. Okay, now? Now it is total 1 plus 1 by x square dx is nothing but dt. By this is t square plus 2. So it is 1 by root 2 square plus t square dt. Look at it. 1 by a square plus x square. Formula is there. That set of 6 formulas, the very beginning, 1 to 10 problems. There, this formula is there. This 1 by a, tan inverse x by a. Here x is t. T means it is x minus 1 by x by root 2. Okay, now, like this. The same model, 24th. 1 by x power 4 plus 1 dx is there. This question is asked in the JEE 2013, I think. This formula is there. This problem is given in that JEE. You see, there the first one x square minus 1 by denominator is same, x power 4 plus 1. Here also x power 4 plus 1. Here also x power 4 plus 1. There is the 22nd problem, x square minus 1 is numerator. Here it is x square plus 1. But here is 1 volt. How can we solve it? 1 by 2. We are dividing and multiplying with 2. This is 2 by x power 4 plus 1 dx. This is 1 by 2. What is 2? X square plus 1 minus of x square minus 1 by x power 4 plus 1 dx. Will agree? This there, it is x square cancel, minus or minus 1 plus 1 to 2 cancel, same. So it is 1 by 2. X square plus 1 by x power 4 plus 1 dx minus integral x square minus 1 by x power 4 plus 1 dx. Okay na? So it is 1 by 2. This is the 23rd problem. Combination of two problems. It is 1 by root 2 tan inverse x minus 1 by x by root 2. Whereas here, this is the 22nd problem. It is 1 by 2 root 2 log of x plus 1 by x minus root 2 by x plus 1 by x plus root 2. Okay, na? Like this. It is the combination of first 1 and 2 problems. 25th other. The same method, related problems. X square minus 1 by x power 4 plus k x square plus 1 is there. It is just like 22nd problem. There x square minus 1 by x power 4 plus 1. But extra kx square is there. This is also same way. X square of 1 minus 1 by x square by x square of x square. I want to write this one plus 1 by x square plus k. Okay, na? Like this. So it is same method. Put x plus 1 by x is equal to some y. It is 1 minus 1 by x square dx is equal to dy. And making square on both sides is x square plus 1 by x square plus 2 is equal to y square. Same method. X square plus 1 by x square is equal to y square minus 2 na. X square plus 1 by x square plus k is y square minus 2 plus k. Okay na? So here it is dy. It is y square minus 2 plus k square. It is 1 by y square minus of 2 minus k whole square. Agree? Now it is 1 by 2a. A is 2 minus k. Okay na? This root is also there. Okay na? Y square minus 2 is there. That is there in the problem root 2 square. But k also you take it. It's a constant. Minus of 2 minus k. And put root and square. Okay now? This is 1 by x square minus a square model. 1 by 2a. It is log of y. Y means 1 by x minus a means it is 2 of 2 minus k with root. K plus x plus 1 plus x is a plus 2 minus k. Let's see. Okay now? Like this. What is k? In the problem we are not given k. Just like x power 4 plus 5x square. Like that we may ask. Okay now? I try to solve it. is according to the positive value, negative value in the root 2 minus k. Okay, na? Be careful about this problem. And one more problem. It is 26. The integral 1 by x of x power 2020 plus 1 is there. It is 2020 this year. How going to solve this one? You see that I will give one formula. X of x power n plus 1 dx. Not only 2002 or whatever it may be the number n. I am taking n. It is x power n minus 1 by x power n minus 1 into x power 1 is x power n of x power n plus 1 dx. Okay, na? That is the logic. Put x power n is equal to t. So n x power n minus 1 dx is equal to dt, na? Yeah. X power n minus 1 dx is equal to 1 by n dt, na? Yeah. So it is x power n minus 1 dx is 1 by n dt by t of t plus 1. That is equal to 1 by n is a constant. 1 by t of t plus 1 dt. Okay, now it is 1 by n integral. It is a partial fraction. 1 by x of x plus 1, just like it is 1 by t minus 1 by t plus 1 dt. You make the LCM. T plus 1 minus t. T cancels, we get 1. It is 1 by n. It is log t, log of t minus t plus 1. So t by t plus 1. Okay, now. So it is 1 by n log of t means x power n by x power n plus 1 plus c. This is the formula. X of x power 1 plus 1 dx. Okay, na? X power n log of x power n by x power n plus 1. 1 by n is there. So like that it is 1 by n means 2020. It is a log of the x power n. X power 2020 by x power 2020 plus 1 plus c. Okay, na? Like that we have to solve the problem. Yeah. Pass.